here to demonstrate how to maximize your game's performance in Unreal Engine. Please welcome Ari and Bjornsson.
Thank you so much. Okay, let's see. So, how many of you have seen a presentation by me before? Hands up. Okay, so a few here and there. So some of you might know that I like to make kind of memories when I go to conferences by taking a selfie with a group. But it's a selfie video, and then I'll put it on Twitter, so you'll all get Twitter famous. Too bad Twitter's going right now. Oh well, maybe Hive or Mastodon or one of those. Anywho, I want to make a selfie with you. Hope you don't mind. If you don't want to be in the video, instead of going like this, go like this. And just a heads up, you're competing with every other conferences I've done this at. So no pressure. But how I'm going to do it is, I'm going to set it up like this. Oh, I'm going to have to come a little closer so we can see past the lights. Oh, God. And actually, can we get the audience lights up a little bit just for this? Oh, thank you so much. I'm going to count down 3, 2, 1, and then we all go hi from Bergen. So let's try it now. Let's try a little warm up. 3, 2, 1. Hi from Bergen. Okay, this was quite good. Not top 3, but very good still. I want to hear a little bit more noise, and I want to see even more hands waving. Let's try it one more time. 3, 2, 1. Oh, yes. I think that was in the top 3. Let's do this one more time. I want the exact same intensity. Like, oh, I have to go all the way here. There's so many of us. Are you ready? Is everyone ready? Okay. 3, 2, 1. Awesome. Thank you so much. This was great. No, let's do that soon. This is my favorite talk. I really like this talk. It's quite interactive. I'll get a little bit on that soon. But I also, as I made it, I've been shuffling the slides around, and I decided, you know what? My favorite slide, I'm just going to put it already at front. It's me. So hi everyone, I am Ari Arnbjo. I'm an Unreal Engine Evangelist at Epic Games. People often ask, Ari, what does an Unreal Evangelist mean? Do you make sermons? Because it's a weird name. I've heard community manager, I've heard developer relations. But basically as an evangelist, I strive to increase adoption of Unreal Engine while helping studios that already use it. And usually that means I can just get 2 birds in 1 stone by doing a presentation about its tech, because I like talking about tech, because I am a programmer, I'm not a marketing specialist or anything like that. And then usually the engine sells itself. I am Icelandic, and I live in Finland. So if you hear me pronouncing some words really weird, that's the reason. And yes, I am a game programmer. I've been 15 years programming in game dev. I've been 20 years programming in general. Some of the things I did before joining Epic Games was I was a lead programmer on Returnal. Did anyone here play Returnal? Has anyone played Returnal? 1, 2, 3, 4, 5, 6. Oh my God, half a dozen. There's half a dozen of us. It's a really good game. If you have a PS5, it's for free now on PS Plus Extra. You will not be disappointed. It's a really cool game. And I've also done, I was working for almost 5 years at Rovio doing Angry Birds. Did anyone play Angry Birds here? Yeah, the audience, of course. If you, I usually ask, like, did you ever play Angry Birds on the bathroom? And then, you know, either you are telling the truth or lying, like, because, yeah, we all did that. Also, you might have noticed there, I put a website, ari.games. It's my own website. Maybe the name gave it away. I put all my presentations on there, so this will be there. I also put all my tips and tricks there. So I always recommend people that are using Unreal Engine, hey, like it's a really big engine. You're not gonna remember everything. So you should have notes or something, like put in a Google Drive or a Word document or something like that, all these little tips and tricks you'll learn. And what I did is that I just took my private notes and I made them public. So there's over 200 tips and tricks there. There's some pages about like finding memory leaks and stuff, because when I was learning it, I was just like, okay, I'm gonna have to write this crap down. So go on there. I paid this custom URL, ari.games. Like, there's no ads on it or anything. It's just so I can tell people, go to my website. So it's like equivalent of a Netflix subscription. So please go on there and make it worth my while. And there's my email and my Twitter and LinkedIn. If you're making anything Unreal, just go ahead and contact me. It's literally my job to be in contact with you all. This is the agenda for today. I recognize not everyone here might be like technical, so I'm going to try to start off quite high level and then kind of like keep going more and more and more and more technical. And I'm going to try to keep it fun also. So it's split in three parts. First, I'm going to be talking about profiling in general. This applies to any engine, any platform that you're doing. So even if you're not using Unreal, you'll hopefully get something out of this talk. Then I'm going to be talking about the tools that we have in Unreal Engine that you will use for profiling. And then lastly, in the end, I will do the practical examples where I took a demo project, I just did horrible things to it, and we're going to find those horriblenesses and fix them together. And that's the most fun part. That's why I left it at the end, so you're going to have to be sitting here with me the whole time. Also, you might notice I have a little tote bag here. So this is like a Christmas bag, because in this thing I have swag. And I'm going to get a volunteer. Actually, Eve, I just asked her. So please give Eve a round of applause. We work together at Housemark. So in this bag is a bunch of reflectors, like this. And the thing is, like, so you know how the Unreal Engine revenue model is. Excuse me. Oh, I'm getting cold or something. So the revenue model is we're only successful if you're successful. And you are only successful if you don't get hit by a bus. And things are getting dark now, you know, winter's coming, everything. So it's in our best interest to keep you alive. So everyone who, like, I will be asking questions throughout, and you should just yell out the answer. Like, I'll go like, and you just go, ah! And then I'll go like, correct, keep your hand up. And then Evie will throw swag at you. Or gently give it to you. We will not try to poke anyone's eyes out. Okay, I think we just start with a question. What's this?
A number.
Yes! Evie, give him swag. This is 60 frames per second. This is the milliseconds that is at 60 frames per second. If no one had guessed this, I would have shown the next number here, 33.33. This is the frame rate for 30 frames per second. So this is your frame budget. You have 16.66 milliseconds if you want to make a 60 frames per second game, which is usually the kind of games you want to make now, unless you're making it, for example, on mobile or console, then you might want to go down to 30 frames per second. And you have this for both CPU and GPU and like any other hardware subsystem that your target platform uses. And you can kind of treat it like money. So some features, for example, they look great, but they're expensive. You basically decide when it's worth it. For example, Lumen in Unreal 5, it's we just, in 5.1, we got it running at 60 frames per second, but it's still taking a chunk of your frame time. So for some people, they're going to be like, it's going to take most of our frame time. We're not going to have a lot of buffer to do much else, but it is an amazing lighting solution. It is completely dynamic global illumination. Of course, we want it. And then we just kind of, budget for it. It's like a wedding. You have a wedding, and then your spouse says, let's say you have 16K of norsk krona for a wedding. And your spouse says, I want 10K of that to be for the catering. And then you might just go like, well, most of our wedding is about the catering, so okay, that's just how expensive it is. Because we all know that if we wanted the game to just run at infinite frames per second, the fastest thing would be to just not draw anything. So we just keep adding until we get close to that frame time, and then we go, looks good, ship it. So for consoles, these are they're cool, they're kind of standard, you know what you're getting. So you can get quite close to the budget. You can be at like almost 16.66. PCs though, they need some leeway for all the different configurations. There's so many different pieces out there, you can't just say all the pieces are going to have this easily, so let's just make this the default. And also, on PCs, usually the users want to be in charge of the budget, not yourself. So they want to say, I want higher fidelity shadows, I want to turn off lumen, I want anti-aliasing or something like that. And then for the amount of users that don't want to do that, like for example me, I don't care. I just want, like, I just bought a new graphics card, put it on max, or I don't have a new graphics card, put it on medium. Or even I don't even want to go into settings, I just want to play the game. So try to make it either like auto-detect a little bit or just have a kind of a little leeway, a margin, so that it has a little bit of breathing space. And then lastly, we have mobile, and they don't have a fan in them, so you need leeway there also for thermal throttling. So we had this, actually on iPhone we don't have this problem that much, but on, there was this, I don't know if it's like that still, but Android, all these different device makers had this competition, like who could fit more teraflops into their phone. So they would put like, this is a tablet GPU inside our phone. This is a laptop GPU in our phone. And you're like, whoa, this GPU is like as big as the phone itself. You run a game for 10 seconds and then it would overheat and do thermal throttling. So you don't want to be that game. Add a bit of breathing space there. When we're optimizing, we often hear this quote, premature optimization. It's the root of all evil. I agree with this, but also like blah, blah, blah. It's quite an absolute statement. So I only mostly agree with it. But the thing about absolute statements, like I don't like absolute statements because we know who it is that only speaks in absolutes. Sith. Okay, I heard like a few people say Sith. Keep your hand up who said Sith, and Evie will give you your swag, or she will try her best. The Sith, they only speak in absolute. Star Wars reference there, so you got to be on your toes. I would say, yeah, of course you shouldn't prematurely optimize. You shouldn't prematurely micro-optimize, maybe is a better term, because as you're making a game, you should of course be performance conscious. Like, don't go completely overboard. Don't make it affect your code readability, for example. If you are code golving, which is like, oh, I'm gonna write this in a way that is like super performant, like, don't do that. You're wasting time. You're making your code usually less readable. Just make the code as readable and maintainable and extendable as possible instead, and only if it's slow, then you can fix it. For example, if you are making a console game, like on one of those set targets, is it already running at 60 frames per second? Guess what? You're done. You can just stop optimizing. So we know when we should not optimize, but when should you actually start optimize? And it has an easy answer. It's just when it shows up on the profiler. So we have this concept of practical optimization. It's like only optimize if you're not hitting your frame times. And how it goes is, how you should be doing it, is that you should be picking the lowest hanging fruit first. Basically go for the biggest impact for the least amount of effort. And then you'll do this once, and usually you'll find somewhere in Unreal, for example, you're like, oh my God, everything's so slow. Well, what is this feature? We're not even using it. Oh, there's a single check mark to turn that off. Oh, wow, we got like 10 milliseconds per frame. That was amazing. That was easy. Big impact, low effort. Then you do it again. You go by the profiler. What's the big chunk there? Okay, let's fix that. You do it a few more times, and it's time to ship. That's how it goes. It always goes like that. So you don't really have time even to do the micro optimizations. You're not going to have time to do the things you want to fix. You should be doing what you should be fixing, which is what shows in the profiler. And also, don't blindly optimize. You should be figuring out the what, the why, and the how. Ari, what's the what, why, and how? Well, good question. I'm glad you asked it. You get some swag there. Awesome audience. So the what, why, and how. I just, like, as I wrote this down, I was like, is this Aris, what, why, and how, or is this just general? I don't know. Maybe this is common knowledge, but at least now we have it written down. So first we go by what. What is slow? You'll go by the profiler. Because if it is slow, if it is time-consuming, it will show up. So you just literally look at the profiler, you'll see like, oh, this is taking a lot of time. And then when you know the what, this is slow. Now you can ask yourself, why is this slow? Why is that thing slow? And then you can, you don't have to guess, you can just, go by facts. Go through its details, because now you have enough info that you can actually start looking into it with, some rationale. And once we know the what, once we know the why, that's when we go for how do we fix it. With all the info, we can now start fixing it, but not before. It sounds very like no-brainer when you see it written down. You're like, oh, of course, I'm always going to do that. You don't even have to tell me, I'm awesome. But I don't know. So I often will, before I made this presentation, I was thinking, how do I usually do it? And often I found myself going directly for the why. Didn't even measure. I would see something, I would see low frame rate, and I'll go like, oh, I wonder why this is happening. Probably because, and then I'll go fixing it already. Or sometimes I wouldn't even ask for why. I would just start fixing blindly. And many smart people I worked with do this every once in a while. So yeah, it's not as much of a no-brainer as you would think. So try to keep this in mind. If you're finding yourself starting to fix something blindly, make sure wait, am I actually fixing the right thing? Is this really the problem? And once you start digging into it, you might learn something new instead of thinking, instead of fixing something that you think it is. So this was the practical profiling in general. Now I'm going to be talking a little bit about profiling in Unreal Engine, the tools that we have. We have two tools. We have lots of tools actually, but the two tools I want to mention in this presentation they should work for most of your cases. We have other like the overlays and the stat system and yada yada yada. But those are the ones I like to use and the ones I recommend you use. First, we have Unreal Insights. We upgraded massively for 5.0, and we keep upgrading it for 5.1. And this is going to be basically our suite of profiling tools for everything except the GPU, because the GPU needs captures. And how you start profiling with that is that you start Unreal Insights from the editor. It's just tools and run Unreal Insights, like in the screenshot over there. Or you can just launch the executable on its own. Just double-click it. It's a standalone program. It's not even inside of Unreal Engine. And then once that is running, you start your game. And that's it. That's all you need to do. Now, Unreal will automatically connect to the local process and use the default tracing channels. The channels is what specific things we are profiling for. The default channels are CPU, frames, log, and bookmarks. And you can override that by adding a start command line parameter. So you do your executable name.exe space -trace equals, then you can even put default there to get all the channels, comma, GPU, memory, file, load time, whatever you want. And making a shortcut or a bat file is handy. And if you are, for example, having playtesters doing something, or if you are running this on a console or mobile or some other target that you can't run the Unreal Insights on itself, you can make it connect to another computer just by using -trace host equals and then put the IP number in there. So this is for everything except GPU. So for GPU, we would make a capture, and there's a command line called profile GPU for that. And you launch it in editor by using Ctrl Shift and comma, or for package builds, or even on consoles and stuff, you can just send the profile GPU console command. And what it does is that it profiles the current frame, and it's compiled out in shipping build. So you have to be a development build or an editor to see it. If you are running it in editor, it will open the GPU visualizer that looks like this. And if you're not running it in editor, it will just print it to the console output. Actually, that was the first two parts. Now we're to the fun part, the practical examples, and now you get to give out some more prizes. I'm going to be asking more questions now. Practical examples. These practical examples, okay, a little bit more slides. These are going to be built on the Lyra Starter game. And this is a sample gameplay project that we at Epic Games made, and we keep updating it. For 5.1, we actually added more updates to it. And this is a successor to the old shooter game. Shooter game was a kind of demo project that we would encourage developers to download and like add to it and make your game even on top of it if you want. It's got a lot of learnings in there. But Lyra is the new one because we kind of stopped updating shooter game, and we learned from that we shouldn't stop updating stuff. So Lyra is now kept up to date as we introduce new features to Unreal Engine. You should check it out already. It's got a lot. It's basically how would Epic Games make a game with Unreal Engine? Lyra. And it showcases a lot of the Unreal Engine 5 features. So we're using gameplay feature plugin there. We're using all sorts of things, and it's you can download it from the marketplace for free. You can build your game on top of it. Like, we don't care. Yes, you can add clown nose on everyone and sell it as a game. Like, that's fine. No one's gonna buy it, but you can if you want to. Just to give you an idea of how permissive we are with it. And yes, it is a really good example. All the team is super, super proud of it because it perfectly demonstrates how to do everything correctly in Unreal Engine 5, and I made it as an example of how to do everything incorrectly in Unreal Engine 5. I did horrible, unspeakable things to it, and I thought it would be cool if we could fix them together. Now we are at the first performance bug, first hitch, first curse, and it is the instance of the low editor frame rate. Someone in the team comes up to me, Ari, and I'm like, what's going on? What's wrong? They tell me the editor is running at 30 frames per second. It was running at 60 frames per second just yesterday. Everything's super slow. Oh, we need to fix it. We need to find it. And I'm like, yeah, we do. Okay, well, I'll try these steps that I just told you before. I'm going to do that for every single example. The what, why, and how. We're going to start by figuring out the what. But first, I want to kind of reproduce this. Like, okay, I want to see what the current frame rate is. How would I do that? Stat FPS, yes, keep your hand up, get some swag. Good one, stat FPS. There is also, the last time I did this presentation, I actually had to fix it because someone told me, you could just press the button. I was like, there's a button? I work for Epic and I didn't know this. It was like, yes, you click the little 3 lines there, the hamburger menu, and there's a show FPS button there. There's even a shortcut, Ctrl-Shift-H. I didn't know that. Anyway, I fixed my slides, so now we have this here now. So you click the show FPS, or like what most of us are used to doing, is that we will go into the console command box and we'll just write stat space FPS. And what that will show is this. We'll get a little green text there. It will show, actually, the team member was right, only 30 frames per second. I don't like when people say, though, like, we've lost X frames per second. Why did it stop? Keep playing for me. Keep playing for me. Okay, anyways. I hope this is not going to happen on the other slides. Just click anywhere. It's okay. It just shows the number wiggling around. So, when someone says we've lost 10 frames per second, what does it mean really? Because if we were running at 30 frames per second, losing 10 frames per second means that the frame got like 5 milliseconds slower. But if we were running at 120 frames per second and someone says we lost 10 frames per second, I'm going to be like, that's margin of error. That's nothing. It's like 0 point something. So usually I would either want to know from what frame rate we went to. It also depends on the target hardware, or just tell me in milliseconds. Ari, we have 10 milliseconds longer frames now. Now I know exactly how long each frame was. The thing is, I just showed you 2 tools. I showed you how to profile on the CPU, and I showed you how to profile on the GPU. So now I want to know which one is taking the most time. How do I do that? Yes, stat unit, I heard. So, swag for you, stat unit. Did you know that there's a button for that also? So, again, hamburger menu, stat engine unit, right there. I didn't know that, so now we all know. Because some people actually do like more using buttons rather than typing into the console stat unit, like we're going to do right there. Stat space unit, and then we do that, and then we get this. Lots of info. So we actually have some repeated numbers there. At the top, we have the old stat FPS. They will not show if you didn't write them before. Then we have the frame time, 33 milliseconds in total, just the same number as above. We have the game thread time, also known as the main thread. And that one's only running for something milliseconds. And I would say that's actually quite good. That's actually very good. If anything, we should add more stuff to it, like make our game more impressive looking, put some AI in there. Isn't that what producers always say? Put some AI in there. Not to knock the producers, you rock, I love you. And then the draw thread is taking 29 milliseconds, 28. The GPU is taking 33 milliseconds, and then the render hardware interface, that's like basically the same as all of these. So basically it's GPU bound. So I'm going to use the GPU tool that I told you about. So we're going to start that up by pressing Ctrl, Shift, and Command, and then it pops up. And in the upper side, you can see a visual representation of the frame. You can click that little white triangle there to go deeper into it and see it like that. I like using the lower tree view because you can sort by duration and see exactly how long each step took in milliseconds. So I can here see that the shadow depths are taking 9.83, lights are taking 5.52, lumen scene lighting 3.484. I'm gonna open render virtual shadow maps, go into batch, raster passes. There's a lot of cursed point lights there that are taking each half a millisecond-ish. Some rectangle lights that are taking 0.01. That sounds more like what we want. But yeah, these cursed point lights are really slow. Then I'm going to go into lights, because that was also taking quite a while. Direct lighting, unbatched lights. The cursed point lights are there again, each taking like 0.30 milliseconds. But the thing is, we just found the what. Now we figure out the why. I'm just going to go and find these lights. So I'm going to scroll down in Outliner. Oh, there they are. That was easy, right there. Going to double click on it. Oh yeah, so they've been put on each side of that door. It kind of looks like what someone would do with lights. I'm going to go through the details panel and see if there's anything weird happening there. So we can see that there's a check mark for shadows. Cast shadows is on, okay. And the attenuation radius is 5,000. How big is that even? So I'm going to just zoom out a little bit, see the bounds of that light. Oh my God. Okay, so each light is lighting the entire level, even though it's that small. So I'm going to fix it. I'm going to start by selecting all of the cursed point lights, and I'm going to decrease the attenuation radius to about 100. So you can see the bounds of them now have decreased, but no visual difference. And I've turned off cast shadows. And look at the time in the upper right corner. It just shot up to 60 frames per second. We just doubled the frame rate, and the only thing we did was change one number, take off one check mark, 0 change in visual fidelity. So these are the things I'm talking about when I'm saying for the lowest hanging fruit, for the least amount of effort, go by what the profiler is saying, because it allows you to find if you've done something dumb like this accidentally. Like maybe someone copied these lights from another part of the level where they were that big, just decreased the light intensity, but it was still casting shadows, it was still super big. Mistakes happen all the time in game dev, and using the profiler is how we're going to catch these mistakes and fix them. Now, let's see what the profiler looks like after we fixed it. What does it show up like in the profiler? Excuse me. So I'm going to press Ctrl Shift and Comma again. The thing pops up. And sort by duration, we can see the frame time now takes 12.96 milliseconds. So we have some spare time even before it goes to 13.3. Here's the lights, unbatched lights. There's one directional light taking 1 millisecond. You always have one directional light. It's probably going to be quite heavy. That's fine. And then I can't even see the other ones. They've just been batched away. That's how you know you should stop optimizing something. It doesn't even show up on the profiler anymore. Okay, that was the first issue, the first curse. Now we're going to go to the next one, the case of the tiny actor with a huge hitch. Exactly. So someone in the team comes to me, Ari. I'm like, okay. I think I'm ready for this. I think I know how to use the what, and how to fix it. And they go, Ari, okay. We have a weird issue. We have sometimes we're loading stuff, and sometimes we're loading this tiny actor. It happens instantly. It doesn't even show up on the profiler. It's super fast. And I'm like, okay, sounds good. Yeah, we're loading it like synchronously. But then we have a level that we're loading asynchronously, and that keeps loading in the background. And I'm like, yeah, okay, sounds good. Yeah, but every once in a while, only once in a while, very rarely, it will just hitch for like 3 seconds. And I'm like, ugh, sounds bad. But luckily, QA engineer managed to make a reproduction level with 2 trigger volumes that you can manage to reproduce it. And I'm like, I love you. So if you don't have those kind of people on your team, get them. They're really good. And for this example, I'm going to package the game so you can see how it's going to work in a game that might have been like made as a development build, not in the editor. So now we're going to package the game. I'm going to go to platforms. I'm going to click on nothing because the video stopped. Let me just go back to the slide. There's a good thing about pre-recorded videos. I can just restart it. I'm going to go to Windows. I'm going to go package content. Select this folder. Looks good. And again, through the power of pre-recorded presentations, it is done. If someone asks you, is this really how fast it takes? Just tell them, yes, use Unreal. Now I'm going to create a shortcut for Unreal Insights. I'm going to get it from the Unreal Engine binaries folder and put it there just so it's easier to start. Everyone in the team can do it. And I'm going to create a shortcut for the Lyra game. Create shortcut there. I'm going to right-click it. And well, I'm going to rename first to start Lyra with Insights. And then I go into its properties. And I'm going to put after the executable in the target. That's where you can put all sorts of command line parameters. In this case, I'm going to write dash trace equals, and then I'm going to put in like whatever channels that we want there. And I originally had this all together. Like I put, here's an example, put lyragame.exe dash trace equals CPU, GPU, frames log bookmark, memory, blah, blah, blah. And then someone on the actual team at Unreal Engine, they went like, Ari, don't do that. Don't recommend that. And I was like, why? Well, memory tracing has a bit of an overhead, so it kind of skews the other results. So you really want to kind of split them up depending on what you're profiling. So I'm like, good point. So I made 2 of them. So if you're doing memory profiling, just do trace default to memory. And in our case, we have CPU and loading profiling. Then I'm going to do dash trace equals CPU, GPU, frame log, bookmark, and then file and load time, because he said something about loading stuff. And then we have here, you might have noticed I put dash stat named events. And what that does is that when you have trace CPU, the dash stat named events will just activate a few more CPU timing events that are usually disabled by default. You don't need them. It's like 30% more of them, but I usually like to have more info than not when I'm doing this. So yeah, I don't even know why we just don't keep it on by default, but that's just how it is. You can see all the trace channels that we have, the list of them, on the Unreal Insights reference documentation page. You can either, I'll just get out of the way so you can see this. You can either just get this QR code and just scan it if you want. Also, this will be online on Ari.games, so you can do it there at your own leisure. Here's the link also directly. The thing is, if you Google this, Unreal Insights reference, it will say in Google, Unreal Insights reference 5.0, and you click it, and it's going to take you to Unreal Insights 4.27 or 26. I don't know why that happens, I'm sorry. But it just changed the URL from 4.26 to 5.0, and it will take you to the right place. I think that's all I want to say about that. Okay, so we're going to do that, what the QA engineer told us to do. I'm going to start Unreal Insights first, have it running in the background, and then I'm going to start Lyra with Insights. And it will already start a trace session in the background. You can see it there. And you can even double click on it and look at it happening live. So like that, I'm going to start it. Yay, okay. But now I'll just minimize it, get it out of the way. I'm going to do what the QA told me. I'm going to run up to the trigger volumes. I'm going to, on the right, we have the one that loads an actor immediately. It's a tiny actor. I'm going to try that. Instant, didn't even notice it. Okay, try the level. Get trace, starting, loading map, level. Wait a little bit. Done loading map. It works perfectly. So I mark this as cannot reproduce. Next issue. The easiest ones are actually the ones that aren't even an issue in the first place. But then QA tells me, Ari, you didn't do it properly. And I'm like, what? No, you have to do it the other way around. Okay, whatever. So let's do it again the way I'm supposed to. So I'll go into the load level async, and then I go in, we actually had about 3-second hits there, like the Jira ticket says. Okay. Very interesting. I have no idea why that is. Like, does anyone know why this is happening? Has anyone had this happen? That's okay, because we will now show you how. Leave it alone, it was done. Okay, anyways, next slide. So, we're gonna open analytics. Here's the timing insights. Let's see what the hell happened. We also have a tab for asset loading insights and stuff. And this is the timeline of the entire application, the frame times up there. And I'm going to turn on some more tracks. I'm going to turn on the graph track that shows you like more relatably how long each frame took. It's usually top docked by default like this, and I like to make it scrollable so it stays out of the way when I scroll down. I'm also going to turn on the asset loading track because it has something to do with the asset loading. So I can see what is loading when. And then lastly, I'm going to turn on the frame tracks. It will just show me what frame is running at each time and how long they are. So this puke of rainbow is just like the stack at each millisecond or at each time. We can see that something looks a little bit weird there. Frame number 548 that took 2.7 milliseconds. Okay, here we can see when we started loading the map asynchronously. You can see the asset. And then we can zoom in by scrolling with the mouse. And if we go up, you can shift and scroll to zoom this line in and out. So you can see almost 3 seconds for that hitch. Okay, quite a lot. So now let's go down the stack. We can see that it only continued once the level was done loading. So it's something to do with exactly the loading of that level. And we can see both the stack for C++ and blueprints here all mixed together. So here we can see we have a function in blueprint called trigger curse load tiny actor, load class asset blocking, which calls load object, which calls load package internal, which calls flush async loading. Okay, so how this works, because someone asked me, was like, what am I looking at? And I realized, I didn't really explain it well. So this shows you the stack, but it's inverted. So the top function is like the first function that was called. Usually it's like the engine loop or like bin, main, start. And then as the lower you go, that's what those functions are calling and waiting for. So we are calling here the function trigger curse load tiny actor, and it took 2.6 milliseconds because it was waiting on load class asset blocking, which took 2.6 milliseconds because that one was waiting for load object, which was waiting for load package. So that's how you read that graph. So we know now what function it's happening. It's something called flush async loading, but we still want to know why. And this is one of the great things about Unreal Engines, that we have the source code for the entire engine. So we can just look into it and see what is happening there. And you can even do it from Unreal Engine. You can just right click it and go to source code. So it will do that. Here we go, load package internal. And I'm just going to start scrolling down a little bit, see where it's loading. And then, yeah, okay. So there we have code that calls load package async. It puts in the package path and the package name. And then if the request didn't return nothing, it will call flush async loading. Flush async loading, that's a concept that is weird. So usually, if you think of loading as in it is going through a pipe, and it's just a pipe that is running in the background while you do something else. That's called the asynchronous loading. Asynchronous because it's doing something not synchronously as what we're doing now. And then when you call flush, what it will do is you're basically sitting by the pipe and say empty, and then you look at it and you wait for it to empty, and you're blocking the main thread. So that's a flush. So why is it flushing? I don't know. Apparently the source code is saying that it seems like to me it's getting the request ID, so it should only wait for that one asset. But I'm guessing because the async loading thread loads everything in a line, it's in a queue. So it's probably waiting for everything before that and then the asset itself. Something like that. I don't know. The only thing I do know is that it's not working in our use case. So what we should do instead is just make it asynchronous loading also. So I'm going to try that. I'm going to open the actor, which is called trigger curse load tiny actor. There's the function load class asset blocking. I'm just going to create a new function or call on a new function called async load class asset. and I'm going to put in the tiny blueprint there, tiny actor. It's actually an empty blueprint for the sake of this demo. And I'm going to drag down the control pins. And you notice I put it down into the completed output pin, but not the immediate exit that is over there. So the reason why I do that is because if we would have exited immediately, then we would have assumed that it was already loaded when it wasn't really. So with the completed one, it will just wait until it is done loading, and then it will print the string, done loading tiny actor. Bad thing about this is now, maybe we expected the tiny actor to load immediately. So now if we try to do this, while we're still loading the whole level in the background, it will just put the level like at the end of the queue. So the level will load, and then the tiny actor will load. I don't really have a really good solution for that, but while I was looking into Lyra to see how they do the things, I noticed in the Lyra Asset Manager they were calling a function in some code file called fStreamableHandle there, wait until complete. Let's read the description now. So it says, blocks until the requested assets have loaded. This pushes the requested asset to the top of the priority list. Oh, sounds good. But does not flush all async loading. So they know, they're like, there's this other function that flushes all async loading, although that function itself doesn't say that. But this one says, we don't do that. And then it says, usually resulting in faster completion than load object calls. This is probably something you might want to look into. Maybe that's going to fit your use case better. Yeah, otherwise, I don't have any more slides on this. It's just we just fix it by not calling anything synchronously or blocking loading. And usually I would recommend that. If you're making a game in Unreal, don't ever do a blocking load ever, because if the asset, like, it just means Unreal will wait for the asset. It will block. It will lag. And usually, like, you might not even get past console certification, because they will say, like, there was a 3-second hitch in your game or a 1 second, and you're like, yeah, it's on purpose. Like, it's not supposed to happen. You might do this in editor tools where you don't care, just like, oh, yeah, it's loading. We don't want to like have to think about the game running without this asset. Sure, your team can do it, but for the user, it's really, really nice in your loading screens if the loading icon goes very smoothly like this, instead of like, like we've seen the games where it's like it's because of things like this. Okay, next example is called Foggy Horror Picture Show. Thank you. It's the only pun of the presentation. No one ever laughs, except Eve did it now, so you can give yourself one swag. Someone in QA comes to me, Ari, and I'm like, okay, yeah, I can do this. Tell me, what is it? Bring it. And they say, oh, something is really wrong. You just start the game and you look around and the frame rate tanks. And I'm like, okay, let's do that. I have the stat unit on to see which one is CPU or GPU, and I'm going to turn around, and the frame rate goes from 60 to 14, 13, 8, 7. Okay, so, but I'm going to write into the console profile GPU, because this is still on the development build and not in the editor. So what it did now is that it did a capture, and then because we're not in the editor, so we don't get the pop-up. But what we do instead is that it gets saved to the log. So now I want to open the log. But where is the log file? Log. Where is the log file itself? In the folder. What's the folder called? How do I find it? Saved! Who said saved? Raise your hand up. You get swag. It's in the saved folder. So I'm going to open the Lyra game, and there's the saved folder. I'm going to go into logs and open Lyra log. There is the capture. I scrolled down a little bit in advance. The thing is, it's not ordered by how long it took. It's ordered by which order it happened in, like which draw calls. So here we can see 90% of the frame is translucency, 90% is after depth of field, translucency, after depth of field parallel. And there we see one record. 90% of the frame, or 135.96 milliseconds, is in a material called cursed fog card particle. And the good thing about using Unreal's tools is that we get some metadata with it. You might see this in other tools, but what this also gives you is that it will tell you which particle system is using it. So there we see Niagara system _ cursed fog, 315 instances, 1 draw call, 630 primitives, 350 vertices. Lots of info. That was the what. What is slow? This material in that Niagara system, particle system. So let's just, now we know the what, let's try to hunt for the why. Why is that slow? I'm going to open the particle system. It's right there, super convenient. And so we have a spawn rate of about 50, which is not that bad for a particle system. But then if we go to initialize particle, look at what's wrong. Well, the size of the particles are really big, 500 times 800. These are really big fog cards. And for kind of half invisible fog cards being 300 something on top of each other, yeah, that could be quite heavy. Here's the material. Okay, so we have a noise node, and it is set to gradient computational instead of sample, and levels 10. Large numbers cost more performance. Okay, another noise node, same levels 10, and then a water noise node that is quality 10. Higher numbers are slower and higher quality. And then over here we have alpha set to 1%, 0.01. Lots and lots of things here that we can fix. Lots of right answers, lots of swag to give out. I just want to hear all suggestions for how could we improve this. Just yell it out. Lower the numbers, yes, what? Yes, pack the textures. You get one, put your hand up. What else could we do?
Lower the particles, maybe?
Yes, it's basically what he said, but yes, lower the particles. What else?
Remove it.
Yes, we could remove it. Sure, that also works. What else?
Higher alpha.
Higher alpha. Thank you. Yes, higher alpha. Also keep your hand up. All really good answers. So let's go through it. Yeah. So one thing is, we could make the noise, instead of being computational, which is not by default, by the way. It is a texture sample by default. I really had to go out of my way to make this slow for the demo because Epic gives us this monster computers, and I'm like, it doesn't get slow. So, okay. So this is my best, like just, it has to get super slow. So instead of computational and instead of being level 10, you could either just make it a level a bit less or just make it a texture sample, which it does by default. I don't know what kind of maniac would make this computational. Alpha, it's way too invisible. It's barely imperceivable. It's like, just make the alpha much higher so you have less of the fog cards in front of each other. So yes, also less fog cards. And actually like the packing, one thing I would recommend is if you look at this, you can see that all of these, like we're basically drawing this end texture here, every single pixel, every single frame. So why not just do all of these offline, like go into Photoshop or GIMP or your drawing program of choice and make this texture here once and then just sample that instead of creating all of these and mixing them together. So there are all these things you could do. All of these are right answer, and all of these add up to make this faster. I don't have another slide on this, so just imagine we did all of this and it runs 60 frames per second. We're all super happy. I also want to mention that because we're basically going for a fog effect, there's also this thing in Unreal called a volumetric fog, which is a 3D representation of a fog, which you actually can represent in a material. You can give a Voronoi noise of a fog. You know, you can make it as shapes. You can do really cool things. So think about just using a volumetric fog. We have one more curse. One more thing. This is the memory leak. Someone comes to me from the team, Ari. And I'm like, what is it, my child? Tell me, I will fix it. I'm getting quite good at this. Okay, we have a memory leak. Yes, we have the tools. Shoot, how do I reproduce it? And they're like, luckily, it's easy. It's very easy to reproduce it. You don't have to do anything. I'm like, oh, you just start the game and keep it running and it will crash. I'm like, okay. On consoles only, though. I'm like, oh, this makes it a little bit harder. Oh, and you have to wait 3 days. Huh? So the reproduction steps is make a build, put it on the console, start the game, don't touch it, wait 3 days, and it'll crash. The thing is, this is a very realistic scenario. You're going to have to make games on consoles that people are going to have to, they're going to want to play the entire game throughout. If your game, 20-hour game, that's a short game nowadays. Can you imagine that? 20 hours. Some people are just going to put the PlayStation into rest mode or Xbox into like whatever it's called there, And then they're going to keep going. And your game cannot have a single memory leak, because if you play your game for, let's say it's an open world game and people want to play it for 100 hours. Some people are only playing the game and they don't want it to crash once. And on consoles, there's no virtual memory. You have this fixed size of memory, like 6 or 8 gigs, something like that, can't remember. And once you run out, that's it. The console just goes, you're dead. The thing about memory leaks, though, that might help us fix this is that a memory leak is a memory leak. Doesn't really matter how much we leak, does it? So if we manage to find just even a megabyte that should be cleaned up, but it wasn't, that might be our culprit. So I'm just going to do that. I'm going to profile the game with the repro steps, but only for 1 minute, because profiling takes a lot of data. Luckily, it doesn't fill your memory, but it does stream it straight to disk. So if you have a big enough disk, sure, it's going to work. But I don't want to buy terabytes of disk. So I am going to turn on memory profiling with the game, and then also to be sure that we're not catching anything that, like, maybe the AI in the background shoots and the bullets are there. I don't want the bullets to count, so I'm going to make the game collect garbage every frame, just so that there's nothing lingering there. So I'm going to start the game. Start insights first, of course, and then I start the game with memory profiling on, and I'm just going to keep it running. And then here I open the console, I write gc.collect garbage every frame, space 1, enter. Now it's collecting garbage every frame, it's running, and I just keep it running for like half a minute to 1 minute, and then I kill the game. That's it. Now, we're going to look into it. Here's the memory profiler. It's the memory insights tab on the top. These green lines you see, those are the bookmarks. So every time a garbage collection happens, that's one bookmark. You can see it here happening every frame. You can, if it's in your way, you can press that little triangle there to turn it off. I want to keep it on in this case. And down here, you will see all the low-level memory categories. I don't really care about the category either, because I want to see it from the stack, so I'm just going to remove them all. You can add them back if you want. And then here we can see, actually, yeah, the memory is slightly rising over time. I'm going to make an memory investigation. I'm going to do, give me memory leaks. Every single allocation that happened after A but before B, that was only released after C. And I'm going to make C just at the end of the game, because if something was made then and not cleaned up before we exited the game, it's going to be a leak. Run query, and then I'm going to go by the preset, and I'm going to set it to call stack. By call stack, give me every single memory allocation depending on where it was allocated from the call stack. 21 megabytes leaking there. I'm going to right-click it and do expand critical path, and it will expand all the way down to the individual memory allocations. There it is. There's the what. We can see the entire stack here. It's in the tick system. We can see actor, tick actor, which calls a cursed actor, : tick. I solved it. It's the naming convention. We've been calling everything cursed. No. Okay, so we know that the memory allocations are happening in the tick function of a cursed actor, and we know that it's not happening in a sub-function because we have a full stack capture. It would show if it was a full sub-function. So it is in that function and nowhere else. And 21 megabytes of memory and 86 allocations. Yeah, they're a bit fat. I made them fatter for the sake of the demo. I'm going to show you the source code for this. It fits on one slide. I'm going to show you the header, and I'm going to show you the CPP. And what we're going to do is that I'm going to read out loud what the code is doing. I'm just going to narrate that's what the code is doing. If you figure out immediately what it is, you can just interrupt me and say like, it's ah! And maybe I'll go like, yeah! Or maybe I'll go like, yeah! It's okay, let's have fun with it. There's no wrong, well, okay, there are wrong answers, but like there's no penalty for getting it wrong. There's a chance of some sweet swag. So here's the code. I'll start reading it out loud now. This is the last, by the way, this is the end. Why is it leaking? First we have the header file. We have an array of structs called fstats captures. And in the tick function, we call the super tick, with delta time, okay. And then we add a new stats capture. We do new stats capture. We put the world get time in seconds also. We're not putting anything else in there. If the stat captures numbers is more than 60, say it again. You never delete the pointers. That's a good answer. Here, you get the big one. You also get a reflector if you want. Never delete the pointers. That's actually a really good answer. A lot of you are going like, what does it mean? I will explain. So yeah, well, if the stat captures number are more than 60, we send it to analytics server, and then we call stat captures.empty. So we're emptying it. But this is an array of structs. It's not an array of pointers. All the memory should be in stat captures. But why is it leaking memory if this is the only place where it can be in? And the thing is, it's this line here. So what's wrong is that, well, actually, like, oh, we have some more swag left, right? Yeah. So what is wrong with this? How do we fix it? Just shout it out loud.
Yeah. I mean, you create a new variable in the heap, and then you instantly dereference it. So dereference to
Music to my ears. I will repeat it to the mic. And how do we fix it?
you can just. I don't use Unreal, but I would assume you can just drop the new and drop the star.
Drop the new and drop the star. Correct. Oh my God, he can get the bag afterwards, but remove all the swag from it. So, okay, I will repeat what he said. The new and the star, what is happening is that it is creating a new object, the new, and then the star there, it used to be parentheses. Actually, this is a real-world memory leak that I've had in a project, and we found it just before we went live, and I thought it was so devious, so clever, I had to put in a presentation. So the new stat capture, already new is a bad word in C++. You never, ever want to use the word new in C++. We have smart pointers that handle the lifetime for you. When you use new, it has to be matched with a delete every single time. And because this is something you have to remember, no one remembers stuff. So we just don't do it. We have smart pointers that automatically deallocate it when it goes out of scope or something like that. So someone maybe, let's say that whoever wrote this was used to writing in C#, and they write new stat capture. And what happens is Visual Studio just goes like, error. What's the error? You're giving a pointer type to where it wants a value type. What does that even mean? I don't understand. Google how to change pointer type to a value type. Google will tell you if you want to change a pointer type to a value type, you have to dereference it, which creates a copy of it. So that's what the star is doing. So what is happening now is we're saying create a new object somewhere in memory, anywhere in memory. I don't care, somewhere in the heap. And then the star is saying, now bring the data of what that pointer is pointing to and put it into the add function of stat captures. The thing is, the stat captures has its own memory. It's already allocated. It's for 30 or 60 instances of it from what it keeps growing itself. But if we take data from somewhere else and we wanted to put it there, it will make a copy of it. So it will go into the array, but the new stat capture that we made somewhere in memory stays somewhere in memory. And then we don't store reference to it, we don't delete it, it is just gone forever. How you're supposed to do it in C++ is for value types, non-pointer types, you're just supposed to call the constructor directly. So you got a little C++ lesson there. Everything is was absolutely correct, smart man. Are you in the industry? Where do you work?
I work with C++ on a daily basis.
Okay, you work with C++ on a daily basis. So, okay. This is basically the end of the presentation. Everything I learned about Unreal Insights was from these two geniuses, Jonut and Stefan, who are working on this system. And they actually have a presentation on how to use it, which is what I watched to make this presentation for you all. So they had of how to use the tool, while mine was more like, this is actual things that you might use the tool for. So you can check out Unreal Insights live from HQ inside Unreal on YouTube if you want to know more about this tool. Here's the QR code, or you can just Google that. Otherwise, are you making something Unreal? I'm the Unreal guy, so I would like to know if you're a studio that we're not in contact yet, to send me an email or connect to me on Twitter or LinkedIn. My DMs are open. I am a LinkedIn whore, so I will just click yes on everyone who is like vaguely in the industry, unless you're a recruiter, sorry. Otherwise, it is time for questions, and it's over. According to the timer, we have 12 seconds
12
for
seconds
questions.
if there's a couple of very quick questions.
Yeah.
I think we can go a couple of minutes.
A
in if,
little hour, yes.
or
So
have
any
you-
questions about... Anyone who asks a question gets swag. How much do we have left? 7. Do we have time for 7 questions? I'm just kidding.
Very quick questions.
Yes. Hello. Do you have any good tutorial examples, or or on your page for learning Blueprint?
Do I have any good examples for learning Blueprint? Not directly related to what we're doing, but luckily we do have a lot of tutorials on blueprints on our community website. That's new. So go to dev.epicgames.com/community, and we have tutorials there, both from Epic Games, which we Evangelist have been doing, and also from the community. So you're going to find lots of there. It's also our forums and Q&A. We would love to have you as a part of our community. So come join us.
Thank you.
Hi. I have a challenge for you. We're a Unity shop,
Okay.
so 30 seconds, where should we switch?
Depends on your use case. If you are making a project in the middle of it, I will not be the guy who says you should throw everything away and start using Unreal. If you want to use Unreal for your next project, I would recommend it because we have so many tools out of the box that otherwise in other engines, I'm not going to name anyone by choice, that you might have to buy separately. So we come as a one-stop engine with everything you need to make a game like Returnal. And you have the entire source code of the entire engine. So if there's something weird, you can just go see exactly what is wrong, fix it yourself, or tell us about it, and we might fix it, and you can get it yourself.
Thanks.
Did you give him swag? Yes. Good.
Hello.
Hello.
We've been doing a project in Unreal, and we did try to change all of the assets into Nanite, which worked pretty just fine. But down the road, when we continued adding more meshes, we started losing frames.
Yeah.
And I discovered that Nanite meshes do not deload with occlusion culling.
No.
Is there a reason for that?
We do have some occlusion culling, but it's happening on the CPU. And I have noticed for some companies that actually like turning off the occlusion culling for Nanite makes it faster, which is interesting. I would recommend, like even though we say Nanite can handle everything like quite well, it is not supposed to work indefinitely into infinity. We still recommend using H-slots, which is what the world partition does by default. So if you have a chunk of land which is far away from you, we actually recommend unloading everything and replace it with one mesh representing all of it, even if that one mesh is a Nanite mesh itself. So you're just doing too much, having too many Nanite meshes. It's not a magic silver bullet that can do everything, but it does make a lot of things easier. But we still recommend using H-slots.
Thanks.
I'm afraid I think we'll have to leave it there.
Okay, how many do we have left? Who wants one but hasn't gotten one yet? Okay, just... Thank you, everyone.
Thank you so much.